control the sea. Got killed by 10 million pounds of sludge from New York and New Jersey.
Alright, good news and bad news. The bad news is we're continuing on with exponential notation, section 2.6, and I said it was going to get hard. It is. That's the bad news. The good news is, rather than doing the rest in 1 day, we'll do the rest in 2 days. So total, we're going to do this section in 3 days. This is day 2. Today, what we're going to focus on, just one thing, negative exponents. What happens when you raise a base to a negative exponent? So you'll see all through the page here, I've gone and written in handwriting here. You might be wondering if I changed any of the questions. I did not. I just made them easier to read. So if you have the worksheet in front of you, it's exactly the same as what I have here. Alright, so we have to figure out what happens when we raise a base to a negative exponent. Let's take an example to help us do that. Let's do 2 cubed divided by 2 to the 6. Now, one way you could do this is to use the quotient rule that we learned last day, and that says if you have the same base and you're dividing powers, what you can do is keep the base the same, and what do you do to these exponents? You subtract them. 3 minus 6, so that gives us 2 to the negative 3 power. Well, it doesn't really help us because it still doesn't tell us what that equals, 2 to the negative 3. But there's another way we could look at this 2 cubed divided by 2 to the 6. We could expand both of these. 2 cubed is 2 times 2 times 2, and 2 to the 6 is 2 times 2 times 2 times 2 times 2 times 2. And remember, when you have the same thing on top and bottom and you're multiplying and dividing, you can cancel them out. So those cancel, and those cancel. What are we left with once we do that? We're left with what's on the top here? You can't put 0, otherwise it'd be nothing at all. If you cancel all these out, what's left is 1 over 2 times 2 times 2, which is the same as 2 cubed. Now, since 2 cubed over 2 6 is equal to this, and 2 cubed over 2 to the 6 is also equal to this, what do you know about the two highlighted parts? They're equal to each other. In other words, 2 to the negative 3 is equal to 1 over 2 cubed. Do you see what a negative exponent does? It flips it over. So the way we write this is a to the negative n. Any number to a negative exponent of n is equal to 1 over a, not to the negative n anymore, to the positive n. Alright, when you see this negative sign here in an exponent, doesn't it make you kind of angry? Aren't you like, oh man, negative exponents, this is going to be so difficult? Don't you kind of say to yourself, you can't say that word, can you? So you don't say that word, you say that flippin' negative. This, I don't like this, that flippin' negative. And that's exactly what this negative does here. This is a flippin' negative. Flippin' negative. It flips the thing over, alright? So let's take a look at a bunch of these and hopefully you'll get the idea. 3 to the negative 2, it's a flippin' negative. It's an exponent with a negative. So it's a flippin' negative. It flips it into the denominator, and now the exponent isn't negative 2, it's positive 2. Oh, well, what is 3 squared? 3 squared is 9. We're finished. Here's another one. 4 to the negative 3. Oh, that negative's a flippin' negative. So we have 1 over 4 cubed. What's 4 cubed? 4 times 4 is 16, times another 4 is 64. Okay, we have two negatives in this one. Which one's the flippin' negative? This is the flippin' negative because it's in the exponent position. This is not a flippin' negative, that's just a negative 2. So, the flippin' negative, we flip the negative 2, so it's now 1 over negative 2. And it's no longer to the negative 3 power, it's to the third power. What does that equal? That equals 1 over negative 2 times negative 2 times negative 2. That equals negative 8. Now, you could keep the answer like that. It's a little bit weird. Usually when we have fractions, you don't put the negative in the denominator. You either put it out front, like this, or you put it with the numerator, like that. These two answers are better. These last two answers here are better. One of those is preferable to this one here. It's not wrong. I don't think I'd mark it wrong. It'd be pretty mean, I think, to mark it wrong. But if you can get in the habit of doing that, I think that'd be better. Okay, here's one we haven't done yet. What happens when you have a whole fraction with the flippin' negative? Well, just like the word suggests, the flippin' negative is going to flip it over. So you have now 4 over 3. Not to the negative 3 anymore, it's now to the positive 3. So that's the next rule I wanted to show you here. If you have a divided by b, like a fraction, and you raise it to a negative exponent, we'll call it negative n, what happens is the fraction flips over, the reciprocal, right? Remember that word reciprocal, flipping it over? You get the reciprocal, and it's no longer negative n, it's now positive n. Okay, back to this question. We actually never even finished it. Or I didn't finish it. You're not doing it, I am. What can we still do in this question? Well, this is 4/3 cubed, which means 4/3 times 4/3 times 4/3. You can do it that way. Or the other way you could think of this question to solve it is you could do spreading the love right here. Right? So this is 4 cubed over 3 cubed. 4 cubed is 64. 3 cubed, 3 times 3 times 3, 27. Alright, next one. Here's a flipping negative. So we got to flip 1 2/3. How do we flip 1 2/3? It's a mixed fraction. You can't. You know what you have to do? You have to turn it into an improper fraction or a top-heavy fraction. So 1 2/3 is the same as 5/3. Right? 1 times 3 plus 2 is 5. 5/3 to the negative 2. Now that's a flipping negative, so we'll flip the fraction. It's no longer negative 2, it's now 2. And then you can either spread the love, 3 squared and 5 squared, or you can think, what's 3/5 times 3/5? Well, 3/5 times 3/5 is 9/25. Good. Okay, here's the last rule we have to worry about with these. You see there's 3 boxes. We've done 2. Here comes the third one. What if the numerator has a flipping negative and the denominator has a flipping negative? Well, they just flip into the different spots. In the numerator, this is in the numerator position, it flips into the denominator. This is in the denominator position, it flips into the numerator position. So the rule right there is a to the negative m divided by b to the negative n is equal to, well, this is a flipping negative down here, so the b is going to flip up to the top, and it's now a positive exponent. And this is a flipping negative, so the a is going to flip to the bottom, and now it's going to be a positive exponent, the m there. Alright, so let's see what happens there. Well, they both have flipping negatives, so the 2 to the negative 5th is going to flip up to the top and have 2 to the 5th up there. And the 3 to the negative 2 is going to flip to the bottom, and you have 3 squared down below. What's 2 to the 5th? 2 to the 5th, 2 times 2 times 2 times 2 times 2, that's 32. And 3 squared is 9. Done. Okay, what if the top one has a positive exponent, in this case 1, and just the bottom one is a negative exponent? Well, then the top one doesn't flip, obviously. It doesn't have a flipping negative. So that would just stay up here, 3. But then this is a flipping negative at the bottom. That's going to come up to the top. So it's going to be 5 squared. Well, what do you do to those two things? You're going to multiply them. So you end up with 3 times 25, which equals 75. Alright, there's a few different ways you could solve some of these. I think maybe the best way to solve this one, 3 squared to the negative 2 power. Do you see this is a power of a power? Use your power rule here. So that's the same as 3 to the, what do you do to those two exponents? You multiply them, right? 3 times negative 2. So you end up with 3 to the negative 4. And we can do that. That's a flipping negative. So it's 1 over 3 to the 4th power. 3 to the 4th power, 3 times 3 times 3 times 3, 81. Okay, next one, again, I would definitely spread the love, I think, with this one. You have to spread it a bunch of times. The 3 can be spread to the 2, to the m to the negative 2, and to the n. So you end up with 2 cubed, m to the negative 2 cubed, and n cubed. 2 cubed, 2 times 2 times 2 is 8. M to the, what do you do to these two exponents? It's a power of a power. You multiply, so m to the negative 6, and n cubed. Now, most of the questions are going to say no negative exponents. We actually don't like negative exponents. You want to get rid of it. So how do you get rid of it? You get rid of it by remembering that this isn't a pain in the butt, this negative exponent. It's a flipping negative. So it's going to flip into the other position, either into numerator or denominator. Right now it's in the numerator position. It's going to flip into the denominator. So on the top, what's left is 8 and n cubed. And on the bottom, the m is going to flip down there. It's not going to be negative 6 anymore. It's going to be positive 6. Okay, are you still with me? I hope so, because it's about to get very difficult, especially these last 3. The first one here, not too bad, but the last 3, very difficult. Okay, I got a whole bunch of bases here of 5. When I see that and I see multiplying and dividing, I think I'm probably going to use my product and quotient rules. So in the top, the numerator here, I have 5 to the negative 2 times 5 cubed. Why don't I combine those? How do I combine them? By adding. So we're going to add negative 2 plus 3. I'll actually write it. Why not? In the denominator, we also have the same base. So we can again add because we're multiplying. What's the exponent here? 1. So you're adding 1 plus negative 3. So you end up with 5 to the negative 2 plus 3 is 1, divided by, on the bottom we have 5 to the 1 plus negative 3. 1 plus negative 3 is negative 2. Okay, this means divide. So when you divide and you have the same base, what can you do to the exponents? You can subtract. 1 take away negative 2. 1 take away negative 3, 1 take away negative 2 is equal to 3. I just want to show you one last thing at this step here, once you got to here. Another way you could do this, I find this quite useful, is if you have the same thing on top and bottom, like 5 and 5, or A and A, or X and X, or whatever, and you want to know how to simplify it, one thing you can ask yourself is, where do you have a bigger number? Look at the exponents. Where's the bigger number here? 1 or negative 2? And I hope you'll agree with me, 1 is bigger than negative 2. Now, how much bigger is 1 than negative 2? If you think of a number line, 0, 1, 2, 3, and negative 1, negative 2, negative 3, how much bigger is 1 than negative 2? It's 1, 2, 3 bigger, so 5 cubed will be right there. I'll show you some more of that down here. I think it's quite useful to do this way. All right, here comes a very difficult one. I'm not even going to read it out or we'll be here half a day. The first thing, there's all sorts of different ways you could do this. I think the best thing to do here is to deal with these negative flippant exponents on the outside of the big brackets. Do that first. So these are flippant negatives. So what's going to happen to this fraction in here? The whole thing's going to flip. So it's going to become c squared on the top now, because it was in the bottom, it's now on the top, and a to the negative 3. It's still negative, right? We haven't dealt with that negative. I know it's a flippant negative, but we haven't dealt with it. It's this flippant negative we're dealing with here. A to the negative 3b on the bottom. All that's happening is we've taken the reciprocal of this, and it's no longer to the negative 4th power, it's now to the 4th power. Okay, same thing with the second one. It's a flipping negative. It's a negative 1 there, isn't it? So we're going to flip the second one as well. So we have a to the 4th, b to the negative 3, all over c to the 5. And that's now not to the negative 1, but just to the 1, which means anything to the 1 power, it's just the same thing. So we don't really even have to worry about that anymore. Okay, the next thing I do is I would do spreading the love. Here, here, and here. So you end up with c squared to the 4th power. You multiply the exponents, you get c to the 8th. A to the negative 3 to the 4th power is a to the negative 12th. We multiply those. And then we have a b to the 4th. Okay, that's getting better. Over here, we can just keep it the same because it's all to the 1 power. So spreading the love makes no difference. Anything to the first power, it stays the same, right? Okay, next thing. Maybe what we want to do now is get rid of these 2 flipping negatives. We still have 2 more flipping negatives. Let's get rid of those. So this flipping negative down here, it's in the denominator. So where's that going to end up? In the numerator. So it's going to be a to the 12th up here, along with the c to the 8th. That just stays where it is. All over b to the 4th. That stays where it is, too. It doesn't have a flipping negative. A to the 4th in the second one stays where it is. But this is a flipping negative, that negative 3. So that comes down here, and it's now positive 3, and c to the 5. Okay, we're pretty much ready to finish this off. Let's look for our a's. We're multiplying along the top here. So we have a to the 12th, and we're multiplying by a to the 4th. What do you do to the exponents? You add them. So you have a to the 16th. Forget about the c for a second. In the bottom, you have b to the 4th times b cubed. What do you do to the exponents? You add them. You get b to the 7th. Okay, now the c's. Again, one way you could do this is you could ask yourself, where do you have more c's, on top or bottom? Definitely more on the top. 8's bigger than 5, so you know they're going to end up with c's on the top. How many more? How much bigger is 8 than 5? 3. Finished. The other way you could think of it is, I'm dividing c to the 8th divided by c to the 5th, and when we do that, when we have the same base and we're dividing, we subtract the exponents. 8 minus 5 is 3. Doesn't matter. Okay, let's keep going. Next one, let's start by doing the same thing. Get rid of the flippin' negative on the outside. So we only have one flippin' negative on the outside. This is fine, that's a positive. So this whole thing's going to flip into the denominator. Wow, that's going to put a lot of stuff in the denominator. What's left in the numerator? Well, you might say nothing, but actually what's left up there is 1. So we have 1 over 2a to the negative 1, I'm just writing this exact thing, b to the 4th, c to the negative 3, but now it's not raised to the negative 2, it's raised to the 2, the second power. This one just stays the same, it's not a flipping negative, so it stays down here, stays exactly the same, like that. Alright, now we're going to spread the love. You got to spread the love here 1, 2, 3, 4 times, and you got to spread it here 1, 2, 3, 4 times. Lots of love spreading here. So we end up with 1 over, in the first bracket you have 2 squared. We know what 2 squared is, it's 4. A to the negative 1 squared, you're multiplying those exponents, so you get a to the negative 2. B to the 4th squared, multiply the exponents, b to the 8th. C to the negative 3 squared, multiply the exponents, c to the negative 6. Next bracket, 4 squared is 16. A squared squared, multiply those, 2 and 2 to get 4. B squared, and c to the negative 4th squared. Multiply those numbers, you get negative 8. Next, we're going to multiply the stuff on the bottom. So the stuff we can multiply together are the numbers, 4 times 16, and you get 64 when you do that. The a's, a to the negative 2 times a to the 4th. What do we do when we have the same base and we multiply? We add the exponents. Negative 2 plus 4 is 2, so a squared. B to the 8th times b squared, multiply those two things, which means add the exponents, b to the 10th. And c to the negative 6 plus c to the negative 8. Multiply those two things, which means add the exponents. That gives you c to the negative 14. Are we done? No, we don't want negative exponents. So we have one negative exponent here. It's right here. It's a flipping negative. So what's going to happen to that c to the negative 14? It's going to flip into the numerator. So it's now c to the 14th over 64a squared b 10. Don't you just love this? Yeah. Tough, eh? I know. It's, as I said, this might have been the thing that gave students the most problems the last time I taught this course. One of the hardest things in the whole course. So if you're finding this really overwhelming, watch the video twice, or ask a friend or come and see me. But okay, one more to go. So again, we have a flipping negative here. This is not a flipping negative. So let's start by flipping. So in the first fraction, we'll end up with x to the negative 3, y to the negative 1. I flipped the denominators to the numerators. And 2 to the negative 2, x, y to the negative 4. It's no longer to the negative 3, it's now to the positive 3. Second one, I'll just rewrite it. I mean, I could actually start spreading the love here, but I'll do that for both of them at the same time. This maybe is a bit of a waste of time, but just so you can follow. It's not a flipping one, that too, so I just rewrote the whole thing. Okay, now we're ready to spread the love, and you have to spread the love a whole bunch of places. 5 here, and also 5 places here. So x to the negative 3 cubed, you multiply those numbers, those exponents together, you get negative 9. Y to the negative 1 cubed, multiply the numbers, you get negative 3. 2 to the negative 2 cubed, you get 2 to the negative 6. Multiply those exponents together. X cubed and y to the negative 12 if you multiply the exponents together. Next one, 6 to the negative 2. Negative 1 times 2 is negative 2. X to the negative 4. Negative 2 times 2 is negative 4. Y to the 4. That's a 2 right there, so 2 times 2 is 4. All over x to the negative 4, negative 2 times 2 is negative 4, and y to the negative 10. Alright, from this point I'll show you in 2 ways how you could do this. One way you could do it is to switch all the negative exponents into positives by doing the flipping. So I think what I'm just going to do is going to draw a red line here to show you 2 ways to go from here. So one way you could switch all the negative exponents to positive exponents. So this is a flipping, this is a flipping, this is a flipping. The only one that's not is that x. So the x is going to stay there at the bottom, that x cubed, but everything else flips. So this x to the negative 9 flips down into the denominator. This 2 to the negative 6 flips up to 2 to the 6 in the numerator. This y to the negative 3 flips to the denominator, so you have y cubed down here. And this y to the negative 12 flips up, so you get y to the 12th up here. Okay, that's the first one. The second one, what doesn't flip here? This y doesn't flip, everything else flips. So let's start with the number. This number 6 to the negative 2 flips into the denominator, so we get 6 squared down here. The x's both flip, so this x to the negative 4 flips up, and this x to the negative 4 flips down. This y stays where it is, that's a non-flipping negative, and this one flips up, you get y to the 10th up there. Okay, let's keep going. 2 to the 6 equals 2 times 2, 4, 8, 16, 32, 64. So we get 64 y to the 12th over x cubed times x9 is x to the 12th. Still have this y cubed. Okay, on this one we have x to the 4th. Y to the 4th times y to the 10th is y to the 14th. Add the exponents. 6 squared is 36, and x to the 4th. All right, can we finish this off this time? Isn't this crazy how much space this takes up? What can we do here? Well, I don't know. Let's keep going. We have 64. We're going to combine these this time. So on the top, we have 4 x's, x to the 4th. We have y to the 12th times y to the 14th, which is y to the 26th. We have to add those exponents. On the bottom, we have 36. X to the 12th times x to the 4th is x to the 16th. And y cubed, oh, that's just y cubed. Okay, at last, I think we have our last step. 64 over 36, you could divide it and get a decimal, but we want to keep it as a fraction. So what you do is you ask yourself, what can I divide? Just like if you had this fraction, 64 over 36, and I asked you to put it in lowest terms, you'd say, well, I can divide them both by 2 and get 32 over 18. I could divide by 2 again and get 16 over 9, and that's it, 16 over 9. So that's exactly what you do here. You think of this like a fraction, and you write 16 over 9. Now, where do you have more x's, top or bottom? Bottom. So how many more are there? 12. Or the other way you could have done that is you could have done 4 take away 16, which is negative 12. That'd be up here though, and then you'd have to flip it into the denominator. That's why I like doing it this way, asking myself, where do I have more? Oh, I have more in the numerator this time. So how many more is 26 and 3? 23. So I have y to the 23rd power. Again, you could do 26 take away 3, which is 23. In this case, it's positive, so it just stays there. Quickly, if I go back here, I could have gone maybe a little fast, quite a bit faster, if I'd done the following. I could have said, okay, 2 to the negative 6, well, that's going to flip up, so that's going to be 2 to the 6. Now, look at my x's. Where do I have more x's? I have negative 9 here and 3 here. Well, that's bigger in the bottom. 3 is bigger than negative 9. How much bigger is 3 than negative 9? 12. So I have x12. Look at the y's. What's bigger, negative 3 or negative 12? Negative 3. How much bigger? 9. So already I can beat that step. Then if I look in the second one and do the same thing, 6 to the negative 2, well, that flips into the bottom, 6 squared. X to the negative 4, x to the negative 4. It's the same amount. They cancel out. Y to the 4th, y to the negative 10. What's bigger, 4 or negative 10? 4. 4. How much bigger is 4 than negative 10? 14. Okay, so now we're already almost done. 2 to the 6 is 64. Y to the 9th times y to the 14th is y to the 23rd. 6 squared is 36, and x12. And then all you have to do is put that 64 over 36 into lowest terms, and we said it was 16 over 9. Add your y 23rd and x to the 12th. So as I said, I like this method of looking for where do I have more x's, top or bottom, and how many more, but you don't have to do that. All right, we're done. I know it's tough. It really, really is. Good luck, and go slow, and don't get frustrated.
Devil is 6.